we are going to discuss solving systems of equations, and we have basically three ways that we need to discuss how to solve systems of equations. One is graphically, and you can solve a system of equations graphically either using technology or by doing it by hand. So we'll talk about both of those. I'll show you both of those. And then there are two algebraic methods of solving systems of equations, substitution and elimination. So before we get into that too much, you kind of have to have an idea of what is a system of equations. Okay, so in order to figure that out, we'll just look at an example. A system of equations is two equations that involve two variables, or three equations that involve three variables. But a system of equations looks something like this. I could imagine x plus 3y is 5, and 2x minus 5y is 12, let's say. That's a system of equations, all right? So when we're talking about systems of equations, we're talking about you guys are only going to talk about 2 by 2. You could have more variables and more systems, but x plus 3y equals 5 and 2x minus 5y equals 12 are both individual equations, but together they form a system of equations which allows us to find x and y. So we can use those equations in three ways. Like I said, you can graph both of them and figure out where they intersect, or you can substitute one into the other, or you can find the same value in front of x or in front of y. So in other words, make them both 2x or both the same number in front of y, and then you can eliminate one of the variables. So when we're talking a system of equations, that's what I mean. X plus 3y equals 5, 2x minus 5y equals 12. Let's solve it. So to solve it, we're going to talk graphically first. Okay, so in order to solve something graphically, all you have to do is graph the two equations, whichever they are. Okay, and you can do that using any of the methods that you want. So you can use x and y intercepts. That's one method of graphing an equation. You can use a table of values where you just pick a couple of x values and find the y value that corresponds to it. Or you can use slope-intercept form where you actually plot the y-intercept and then you go from there over and up, rising and running as your slope dictates. So you can use any of those methods, but you're essentially going to graph each of the lines. And then once you've graphed them, the second step is to look at the intersection. What is the intersection point between the two lines? And that's the solution to your system of equations, because the solution is going to give you an x value and a y value. That's the idea. So we'll do a couple of examples of this, but as we do, it's important to recognize that graphing is not a great method unless you know for sure that your answers are integers, first of all, and that you do a really good job of drawing the graph. Because if you don't do a good job of drawing the graph, in terms of setting a scale, putting it on a grid, all of that, then you're going to have a possibility of finding an intersection point that doesn't actually solve the equation. So you've got two things that you have to think about. Can I draw this graph accurately? And then if I can, is the solution going to be an easy one to spot? In other words, they're integer values, so they're on the grid. If they're not on the grid lines, then it becomes a little bit harder to know exactly what they are. So we're going to look at a couple of examples, but they're going to be relatively simple. Okay, so the first example is this one, x plus y equals 10, and x minus y equals 4. So if I'm going to solve this graphically, the first thing I'm going to do is find out where my x and y intercepts are, all right, for each of these. So my x-intercept is when y is 0. So if y is 0, x is 10. And then my y-intercept, the same thing. I let x be 0, and I get y to be 10. Okay, so my x and y intercepts for this one are 10, 0, and 0, 10. Now I'm using that method because it's an easy one to use in this case. You can use any method you want. In other words, you could solve this for y and use the slope-intercept method. It doesn't matter. But that's what I'm going to do for that one. I'm going to do the same thing down here. So the x-intercept for the second one, again, it's when y is 0. So I'm going to get x is equal to 4. So that means my x-intercept for that one is 4, 0. And my y-intercept for that one is when x is 0, so I'm going to get minus y equals 4. So y is equal to minus 4. So my y-intercept is 0 and minus 4. So I'm going to try to plot these. Okay, so to do that, I'm going to have to put a scale on here. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. And I'm not going to draw each grid line for the rest of them, but there's 10. There's minus 10. And down here is a minus 10. So if I graph, first of all, I'm going to graph this one in blue. So 10, 0 is right here. And 0, 10 is right here. And then what I'm going to do, because I can, is get an actual straight line and draw it between those two. Okay? And then I'm going to do the same thing with the second one. I'm going to plot that with my red pen. So I'm going to be at 1, 2, 3, 4, and 0 right here. And then I'm at 0 and minus 4. So 1, 2, 3, 4. So there's 0 and minus 4. And again, I'm going to draw my line. And I'm going to try my best to draw that as straight as possible. Okay, and then what I'm going to do is I'm going to notice that there's my intersection point right there. That's my point of intersection. So I just read what that is off the graph. So 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. That's point 7 and 3. So that's my solution. So my answer is x equals 7 and y equals 3. Okay, now we can check our answer. The nice thing about solutions like this with equations is that we can check our answer. So we can say, is 7 plus 3 10? And I say, yes, it is. And then is 7 minus 3 4? And I say, yes, it is. So I know then that this is the correct solution. Okay, and all I'm doing is plugging in x plus y, 7 plus 3, and then x minus y, 7 minus 3. All right. So that's how we solve a question graphically. So let's look at a second one. Okay, 2x minus 5y equals minus 10, and then 4x minus 10y equals 20. So I'm going to start by finding the x and y intercepts of each of these. So the x-intercept here is going to be, again, y is 0, so 2x is equal to minus 10, which means that x is minus 5. So my x-intercept is minus 5 and 0. My y-intercept, I'm going to minus 5y is equal to minus 10. So I'm going to let x be 0. So y becomes 2 divided by minus 5. So my y-intercept is 0 and 2. For the other one, I'm going to have x-intercept of 4x is equal to 20 because I'm going to let y be 0. So that means x is 5. So my x-intercept is 5 and 0. And then my y-intercept is going to be minus 10y is equal to 20 because x is 0, so it just goes away. And so y becomes minus 2. So I have 0 and minus 2. So I'm going to plot these, and I'm going to, again, just go with a scale of 10. So this is 10, this is 10, minus 10, and minus 10. And if you don't have a ruler, I would encourage you to get one because I'm drawing with our notebook. I can draw an actual straight line that I know is straight because it's built into the computer. But if you just try to sketch 2 points and then once you've plotted them, it isn't accurate, you're going to end up with the wrong answer. So you got to really make sure that you can get a very straight line. So I'm going to plot these two. So minus 5, we go 1, 2, 3, 4, 5. There's minus 5 and 0. And then 0 and 2 is right here. Okay, so I'm going to draw a line through those two. And it looks like that. Okay, and then the second one, I'm going to do the same thing with those points. I'm going to plot them first. So 1, 2, 3, 4, 5 right here. 5 and 0. And then 0 and minus 2 is right here. Okay, and if I do that, I'm going to have to fix this a little bit. It didn't quite come out straight, but if you look at that, then I think you can probably see that those do not intersect, at least not on my graph. So then that gets me wondering, well, what happened? So I say, in this case, there is no solution. There is no answer here because there is no intersection. But then I go, well, that's weird. I wonder why that happened. And if I look up here, I think you can probably see that this is the same equation, essentially, on this side. So if I take this and I multiply it by 2, okay, I'm going to get 4x minus 10y, right? But on this side, when I multiply by 2, I'm going to get minus 20. So what that means is I essentially have the same thing on one side, but a different thing on the other side. So these equations are parallel. They have the same slope, but they're not going to intersect then because they don't have a similar point. In other words, 4x minus 10y is equal to minus 20, and 4x minus 10y is equal to 20. They can't both be true at the same time. So that's why there's no solution. So that is how you solve a system graphically. Then we get into the other two methods. The second method is elimination. And essentially what you're trying to do is you're trying to eliminate one of the variables. Okay? So what you're trying to do is either add the equations together or subtract the equations so that one of the variables disappears. So you essentially line them up, and then you make sure that the x values are the same or the y values are the same, meaning the constants in front of them are the same, okay? And then we add or subtract the equations. So here's an example, and I'll show you this. This one's a pretty simple example, but essentially what we do is we say, looking at these two equations, the x values are the same. So what I'm going to do is I'm going to take this equation and subtract that equation, all right? I'm going to subtract them. So x minus x goes away. Y minus minus y gives me 2y, and 10 minus 4 gives me 6. So then I say, well, that means that y is equal to 3. And then I say, therefore, x plus 3 is equal to 10 if I substitute back into this equation. So that would mean that x is 7. And it doesn't matter, you can plug into either equation. So you can say, I could have went back to this equation instead and said x minus 3 is equal to 4, which would then mean that x is 7. It doesn't matter, you'll get the same thing. So my answer is 7 and 3. Okay, now what's interesting about this is you might say, well, you got rid of x, why did you do that? Well, I just chose to. Could I have gotten rid of y instead? And the answer to that question is yes, I could have. So if I was going to get rid of y, I would have added these equations. I would have went plus instead. So x plus x, that's 2x. Y plus minus y, that's 0. And I've written in 10, I should have written in 4 here. And then 10 plus 4 is 14. So I get 2x is 14, which means x is 7. And then I would go back to one of these two equations, doesn't matter which one, but I go 7 plus y is 10, which means y is 3. So either way, I still get a solution of 7 and 3. It doesn't matter whether I eliminate x or y. It doesn't matter once I've eliminated them which one I plug back into. I still get the same answer. So that's the method of elimination. Okay. Now we'll look at another example because the first one was pretty easy. So when we look at this one, what I notice is that the x values are not the same number. One's 3, one's 2. Okay. And then the y values are not the same number. One's a 2 and one's a 1. So in order to get them to be the same, I have to multiply by something. So what I'm going to do is I'm going to multiply this second equation by 2. Okay, and what that's going to give me is the first equation stays the same, 3x minus 2y is equal to 18. But the reason I'm multiplying by 2 is now I'm going to get 4x plus 2y equals minus 4. And now the y values, you'll notice, are the same. They both have a 2 in front of them. Now because they're opposite signs, that is, this is negative, that's positive, I'm going to add these equations. All right, so I'm going to go plus. So 3x plus 4x is 7x. Minus 2y plus 2y, that's 0y. And then 18 plus minus 4 is 14. So that means that x is equal to 2. And then once I know that x is 2, I go back up to one of my equations. It doesn't matter which one. Okay, you can plug into either one. What I usually do is pick the simpler one to plug into. So because this has smaller numbers, I'm going to plug into it. So I'm going to say 2 times 2 then plus y is equal to minus 2. So that means that 4 plus y is minus 2. And if I bring the 4 over, I get minus 2 minus 4. So y would be minus 6. So my solution is 2 and minus 6. And what you can do if you want to is you can actually check that in the other equation. So I can say, let's check that to make sure that it works in the 3x, so 3 times 2 minus 2y, so 2 times minus 6 is equal to 18. Let's see if it actually is. So 3 times 2 is 6, minus 2 times minus 6 is 12, and 6 plus 12 is 18. So I say, yes, it does work. All right, and I know it works in this one because I use this one to find the y value. So I know that I'm right then. So that's the nice thing about this solving, is that when you solve, then you know whether you're right by plugging the numbers back into the equation. Okay? So if we look at this one, another example, same idea. I want to get either the x values the same or the y values the same. Okay? So what I'm going to do, this time I'll do the x values. I'm going to multiply this equation. I want it to be 1/2, and right now it's 2/3. So if I multiply it by 3/4, okay, then just to show you where I'm getting that from, 2/3 times 3/4 is going to end up giving me, the 3's are canceled, and I'm going to get 2 over 4, which is 1/2. So if I multiply this equation by 3/4, I'll get 1/2. So I'm going to do that. So 2/3 times 3/4 I already know is 1/2 x. Then I have to do 3/4 times 1/2. So that gives me 3/8 of y. And then 3/4 of 10 is 30 over 4, which is reducing to 15 over 2. So that's that equation. This equation now is 1/2 x plus 2/3 y is equal to minus 5. So then I am going to eliminate x by subtraction. I'm going to subtract these. This is going to get a little weird because I have to subtract then minus 3/8 here minus 2/3. Okay, so let's do that. Minus 3/8 minus 2/3. I need a common denominator. So I'm going to put them over 24. So this is going to be minus 9 over 24 and then minus 16 over 24. So that's going to give me minus 25 over 24. Okay? And then I have to also do a second calculation of 15 over 2 minus minus 5. So I'm going to have 15 over 2 minus minus 5. So that gives me 15 over 2 plus 5. And 5 is 10 over 2. So that's going to give me 25 over 2. Okay, so I'm going to write that in there. I'm going to have minus 25 over 24y is equal to 25 over 2. So then y becomes 25 over 2 divided by minus 25 over 24. So that is 25 over 2 multiplied by minus 24 over 25. And if you divide the 25s, I get minus 24 divided by minus 2. Sorry, minus 24 divided by 2, not minus 2. And I get minus 12. So y is minus 12. Then I say, okay, let's go back then up here. And if y is minus 12, what's x? So I'm going to plug it into this equation now. I'm going to say 1/2 x plus 2/3 times minus 12 is going to equal minus 5. So 1/2 x, 12 times 2 is 24 divided by 3 is 8. So I'm going to get minus 8 is equal to minus 5. That means that 1/2 x is going to be minus 5 plus 8. So half x is going to be 3, which means that x then is 6. So my solution is 6 and minus 12. I say therefore the solution is 6 and minus 12. That's my solution. Now, I can check my solution, okay, by plugging it back in here. 2/3 of 6. I'd say, well, 6 divided by 3 is 2. 2 times 2 is 4. So this becomes 4. And then plus 6, because it's half of 12, does give me 10. So I'm confident then that that's my solution. I know that that is then right. So that's the method of elimination. The third method is the method of substitution. So the method of substitution is exactly what it's describing. You solve one of the equations and then substitute it into the other. Okay, so to do that, I'll show you what I mean. We imagine, I'm just going to label these equations 1 and 2. Okay, now, just before I continue, I want you to understand that any of the methods work for any of the equations. You could graph these every time you could graph. It's just that it's not very accurate. You could every time use elimination. It will work. And you could every time use substitution. So the fact is that you get to choose. You have a choice. The way that I choose is based on which one's the easiest to do. So when I look at any equation, if I have a variable like this that has no number in front of it, that's easy to solve for. So what I'm going to do for substitution, I'm going to say, look, in equation 1, I can take 2x plus y equals 5, and I can solve this for y very easily, right? Just by bringing that 2x to the other side. So y is minus 2x plus 5, okay, or 5 minus 2x, if you want to write it like that. So the way substitution works is we say, therefore, then in equation 2, we're going to replace y. So we're going to say 3x minus 2 times, and instead of y, we're going to write minus 2x plus 5. And then that equals 11. So that means that 3x plus 4x minus 10 is equal to 11. So 7x minus 10 equals 11. That means that 7x is equal to 21 if you add 10 to both sides, and so x is 3. Now, because we know x is 3, we can go back up here and say, well, then I have an equation for y right here, right? I know y is minus 2x plus 5, so I can say y then is minus 2 times 3 plus 5. So that's minus 6 plus 5, which means that y is minus 1. So my solution is 3 and minus 1. Now you can quickly check that. Just go back here. 2 times 3 is 6, minus 1 is 5. Yes, it works. 3 times 3 is 9. 9 plus 2, because minus 2 times minus 1 is 2, is equal to 11. So I'm confident then that that is the right answer because it works in both equations. And that's the wonderful thing about solving systems of equations. You can always know that your answer is right or that it's wrong. You might not know how to fix it, but you always know whether you're right because you can just plug the answer into the equation and see if it works. Okay, so that's the method of substitution. So let's do another example here. I'm going to label this equation 1 and label this equation 2. All right, now, in this instance, there is no number that's by itself. In other words, there's no variable, sorry, that has just x, all right? Because there's a 2 there, there's a 3 there, there's a 4 there, and there's a 5 there. So it really doesn't matter which one you choose. I'm going to choose to go in equation 1. I'm going to make this equation solved for x, all right? So I'm going to have that 2x is minus 3y minus 11. And so x is minus 3y minus 11 divided by 2. Okay? So then I'm going to say, therefore, in equation 2 now, 4 times x becomes 4 times minus 3y minus 11 divided by 2. And then minus 5y, and that equals 33. So 4 divided by 2 is just 2. So I'm going to end up multiplying these two numbers by 2. So that gives me minus 6y minus 22. And then minus 5y, and that equals 33. So that gives me minus 11y minus 22 is equal to 33. If I bring my minus 22 over, I get minus 11y is 55. And that means that y is minus 5. Okay? So then I say, therefore, x is minus 3 times y, which is minus 5, minus 11, divided by 2. So that gives me 15 minus 11 divided by 2. So 15 minus 11 is 4 divided by 2, so 2. So that's my solution then, is 2 and minus 5. That's my final solution. Okay? And again, you can check your answer. If you go back up here, 2 times 2 is 4, minus 15 is minus 11. 4 times 2 is 8. 8 plus 25 is 33. So I know that I'm right. And I would encourage you to do that. Okay, every time. Excuse me. So you can practice from these questions, and you should have those sent to you or posted on Teams or something like that. But you can practice these questions, but those are the 3 methods. All right, now, the other thing you're going to be asked to do is to solve problems using the systems of equations. Okay, so I think what we'll do is we'll stop the video here. I'll pause it here, I'll stop it here, and you can practice just solving equations using elimination, substitution, or graphing. And then we'll do a second video on the problems, the word problems. So we'll stop that there for now, and you can practice. If you have questions, you can contact your teacher and ask them for help. And then we'll talk in the next video about the systems of equations being applied to actual problems.